Hi, welcome to this video. In today's video, I'm going to look at a very interesting sum of 1 over n to the fourth, okay, as n goes from 1 to plus infinity. In order to evaluate this sum, I'm going through the Fourier series, okay, the general formula for the Fourier series. So in this case, as n goes from 1 to plus infinity, okay, let's set. What I'm going to do now, I'm going to calculate the coefficients a sub 0 and a sub n, okay. So a sub n equal to 1 over pi. We previously did the same thing with the 1 over n, the sum of 1 over n squared. So a sub n equal to 1 over pi from minus pi to the pi f of x is multiplied by cosine nx, and b sub n equal to 1 over pi is multiplied by minus pi to the pi f of x sine nx, but equal to 0, because this function is an odd function, okay. This function is an odd function. What I'm going to do now, I'm going to calculate a sub 0, 1 over pi minus pi to the pi f of x is x squared dx. As you see here, this function is an even function, so we don't have to calculate this integral on the bound minus pi to the pi. I can do that like this, 2 over pi. This integral equal 2 times from 0 to pi, okay? X squared dx. So the integral 1 over 3 x to the 3 from 0 to pi, which is, if you calculate this one, is given as, is multiplied by 1 over 3 pi to the 3 minus 0. I'm going to cancel 1 of the pi, 2 over 3 pi square. Okay, now I'm going to calculate e sub n. Okay, e sub n equal to 1 over pi from minus pi to the pi f of x. We have x squared cosine nx dx. Okay, it's the same thing here. This is the even function, so I don't have to calculate the integral over minus pi to the pi. I don't have to calculate the integral over minus pi to the pi. I can do 2 times this integral from 0 to pi x squared cosine nx dx. Okay, there is a technique how to evaluate a sub n without doing integral by part all the way down. Okay, so you don't have to do that. Just I'm doing the shortcut for this one. I'm gonna have two functions. As we have two functions, we have x squared, we have cosine nx. I'm going to derivate this one. This is plus sign is giving us 2x with minus sign. The derivative function of minus 2x, which is minus 2. This is become plus sign 0. Okay. This one for cosine nx, I'm going to integrate this one. Is given as 1 over n sine nx. The integral of this one is given as minus 1 over n squared cosine nx. The other one is coming minus 1 over n to the minus 1 over n cubed sine nx. If you integrate this one, it's taking you back to this one. If you integrate this one, it's taking you back to this one. If you integrate this one, it's taking you back to this one. Here the inverse. If you derivate this one, it's giving you minus 2x. If you derivate this one, it's giving you number 2. If you derivate number 2, give you 0. But regarding with respect to the sign plus and or minus, the first one is plus, the second one is minus, third one is plus, the last one is plus. The last one is minus, which is 0, okay? So now this one implies, so this is just shortcut, okay? So we have a sub n, So what I'm going to do now, I'm going to multiply this one by this one, this one by this one, this one by this one. Okay? So now I'm going to evaluate this one. We have a sub n equal 2 over pi outside. Okay, as we have here. So this one is multiplied by this one, which is x squared over n is multiplied by sine nx. Second term, minus 2x is multiplied by minus 2n. Minus 2x is multiplied by this one, is giving us plus 2x over n squared cosine nx. The last one is multiplied by minus plus 2 is multiplied by this one, is giving us minus 2 over n cubed sine nx. From 0 to pi, I'm going to evaluate this one. We put 2 over pi outside. This one equal to 0 because sine of pi, if you replace pi into sine, is giving you 0 because sine of n pi. Second one, the last one equal to 0 as well because we have sine of pi equal to 0. What's left? This one. So this one, if you replace pi here, is giving us 2 pi over n squared is multiplied by cosine n pi. Okay? I'm going to simplify this one a little bit. I will have 4. Pi is going with pi. Pi will be cancelled out. So I will have 4 over n squared. Cosine n pi, you can rewrite it on this form, minus 1 to the n. Okay? So this is the a sub n. So the a sub n equal to 4 over n squared minus 1 to the n. Okay? So we already calculated e sub 0 and e sub n. I'm going to bring this one at the top and continue with our problem. In the last board we were working on the Fourier series. We came up with these results. A sub 0 equal 2 over 3 pi squared and a sub n equal to 4 over n squared is multiplied by minus 1 to the n. Okay? I'm going to apply the Parseval theorem. Parseval. What's the Parseval theorem says? We have a sub 0 squared over 2. This is Parseval theorem. Okay? So everywhere we have f of x equal to x squared. Okay? So this one equal to, we already found equal to 0. So, and then also, and we have a sub 0 equal to 2 over 3 pi squared. This means a sub squared, a sub 0 squared equal to 4 over 9 pi to the 4th. Okay? So a sub n equal to 4 over n squared minus 1 to the n is giving us a sub n. So this one comes with the absolute value, but you know this is usually we have to do the absolute value. So the absolute value over n squared minus 1 to the n. But since one is positive, so we don't need absolute value here because everything is positive. Okay. The Parseval theorem comes with the absolute value. Okay, absolute value here, but everything is positive, so we don't need absolute value. If you take the square of this one, is giving us 16 over n squared minus 1 to the 2n. Okay, so this one is minus 1 to the n is become plus 1, which is positive. So this one will have 16 over n squared. You have 1 over pi, integral minus pi to the pi, f of x squared, which is x squared quantity square dx. So as you see here, this is the even function. We don't have to calculate. So since this is even function, so I have 2 times this integral equal to 2 times over pi from 0 to pi x to the 4th dx. Okay, I'm going to evaluate this one. It's simply, this is straightforward integral. So 2 over pi is multiplied by 1 over 5. Okay, over 5 x to the 5 from 0 to pi. Okay, so this one equal to 2 over 5 over pi is multiplied by pi to the 5. Okay, I'm going to simplify one of pi from this fraction, so I will have, so this one equal to 2 over 5 pi to the 5. Okay, 2 over 5 pi to the 4th. Now I'm going to plug everything in this equation. I'm going to plug everything into the origin equation. 1 over 2 is 4 over 9 pi to the 4th plus the sum of this one, 16 over here, so here to the 4th, because when you take the square it's giving us 4th here. Okay, so this one 16 over n to the 4th, as n goes from 1 to plus infinity, equal to this integral, which is 2 over 5 pi to the 4th. Okay, so I'm going to simplify this one a little bit. This 16, I take this 16 outside because it's cancelled as a constant. Okay, now 2 will be cancelled out with this 2, it will become 2. Take off this one. Now I'm going to simplify number 2 from both sides. I will have number 1 here. Here will become 8. Here become 1. Because we are dividing by 2 on both sides. So what's left here? So this one equivalent. I'm going to bring the pi terms to the other side. So we'll have 8 is multiplied by this sum, 1 over n to the 4th, as n goes from 1 to plus infinity. We have pi to the 4th over 5 minus 1 over 9 pi to the 4th. Okay, I'm going to divide by 8 the sum of 1 over n to the 4th, as n goes from 1 to plus infinity. Okay, equal to pi over 4th, 1 over 5 minus 1 over 9 is multiplied by, I'm dividing both sides by 8, so I'm going to calculate this sum. I'm going to cancel out number 4. I will have 2 times, I will have this one, pi to the 4th over 90. Okay, so the sum of 1 over n to the 4th, as n goes from 1 to infinity, equal to pi to the 4th over 90. Okay, I have done with this problem. Thank you for watching. I will see you in next video. Bye.